Quadratic equation. Right? I don't know how to hide this thing. Equations. I like to leave that up there so that I can pause when I need to pause and stuff like that. So quadratic equations are equations that have a what in them? A squared in them, right? Quadratic equations, they have a squared in them. So they are usually of the form, this is called standard form. F of x is equal to ax squared plus bx plus c. And by the way, this whole, all of chapter 3 is all about various types of functions. So they talk about quadratics first, then they talk about polynomials like cubics and quartics and higher degree polynomials. And then they talk about rational functions, which are ones which have asymptotes and stuff like that. And that's the harder part of it. But this I think you have all seen before. What shape does this make if I graph it? It makes a parabola. You see parabolas in real life anywhere? No? Well, where do you see parabolas in real life? Huh? In whose art? Oh, in the St. Louis art. I think that's not really a parabola, though. I don't know. Maybe it is. Okay. Where else? Yes. Brent. Brett. Yeah, that's like in projectile motion. You see that a whole lot. Okay. So there's lots of places where you see rocket, cannonball, baseball. Okay. And so on and so forth. So we're going to kind of start with a simple one. If we have y equals ax squared, okay? Who can tell me what this a does to my parabola? What does my a do to my parabola? Yes, Mr. Logan. It's the stretch, okay? So we know that if a is bigger than 1, okay, it actually, if the absolute value of a is bigger than 1, okay, and this is compared to y equals x squared, okay, compared to y equals x squared, if the absolute value of a is bigger than 1, that means it gets skinny. Did you know that? You knew that, didn't you? Did you know that? Okay. And if the absolute value of a is less than 1, okay, then it gets that. I'm down with that. That's not how you spell fat. Or you can call that wide or something like that. Okay? So in this case, if I were graphing y, if this is y equals x squared, okay, and if I want to graph like y equals 2x squared, it would be inside that one. It wouldn't be up higher. It would be have the same vertex. And if I want to graph y equals 1/2 x squared, it's going to be like something down here. Okay? What if a is less than 0? A is negative. Then what happens? It flips, right? It's upside down. So if a is less than 0, it kind of goes like that. Okay? Okay. So you can tell if it's skinny, if it's wide, if it's upside down. So you can tell a lot about a parabola just by looking at that little equation there. Who can tell me what C is? What's C? Yes, Sam. See it? Not the vertex, not in this case. What's C there, Jason? That's the y-intercept. So C in this case is equal to the y-intercept. Okay, because think about it. If I plug in 0 in here for x, what am I going to get out? What's going to come out? C, right? And so the y-intercept is the place where x is equal to 0, right? And so that's what I see as the y-intercept. And so say, for instance, I wanted to graph in general y equals negative 1/3 x squared plus 2. Could you give me a rough idea of what that would look like? It would be an upside down parabola. What would be it? It would be a fat one, okay? And it would go through what? Y equals 2. And it would be kind of wide. Okay? Now, if I want to find what those x-intercepts are, x-intercepts, all you do is you set y equal to 0, okay? So in this case, this is going to be a little bit ugly, but we're going to do it anyway, okay? So in this case, I'm going to put y in here. I'm going to say negative 1/3 x squared plus 2, not 1. I'm going to subtract from both sides. I get negative 2 equals negative 1/3 x squared. I am going to multiply through by negative 3, which gives me 6. Isn't it? Yes. Positive 6 equals x squared. So x equals plus or minus the square root of 6, which is about something, 2 point something, right? So that's where it's going to cross. This is positive square root of 6. And over here, this is negative square root of 6, comma 0. Yes, sir.
If I shift the graph left or right, C is going to be the y-intercept.
Yes, C is still going to be the y-intercept.
I mean, if I shift it to the left or the right, I mean, the intersection of
It's still going to, yeah, no, man, because you could have like y equals 3x squared minus 2x plus 7. Yeah, it's not going to be the vertex, but it's still going to be the y-intercept, right? You understand? If it's just like this, that's going to be the vertex. But if it's something like this, 7 is the y-intercept. It doesn't go, right, it's not centered, it's not symmetric with respect to the y-axis, but it's still, okay? I think you guys know, is it recording again? It is. Yay, I need a new piece of paper. Vertex form. And we went over this on the summer package. Vertex form. Y equals ax minus h squared plus k. You've seen that before? You should have seen that on your summer packet more than once. So say for instance I have y equals x squared minus 6x plus 1. Y equals x squared minus 6x plus 1. And they tell you I don't like grid. Put in vertex form and sketch the graph. Okay? So that's what we're going to try to do. So you have to do that thing called completing the square. Remember that? Some of you remember that? So what I'm going to do, I'm going to come over here, y equals, I'm going to take half of the negative 6. Okay, so I'm going to go x minus 3. And I'm going to square it, okay, plus or minus something, okay. This is actually going to be minus something, plus 1, okay. And the reason I did that is because if I FOIL out x minus 3 times x minus 3, what do I get? Minus 6x plus 9, right? And so I almost have x squared minus 6x, but I don't. I've added 9, right? So because I added 9, what do I need to do over here? Take away 9, right? And that keeps that thing being the same, okay? So now in vertex form, I have y equals x minus 3 squared minus 8, okay? Oh, in this case, HK, of course, is the vertex, right? That's the vertex. Okay? And A is like the stretch. Well, in this case, A is 1, so it's not stretched yet. Okay. So then I could sketch a graph of it, right? I can put my vertex at, since this is minus, whoops, I messed up. That should be minus, right? I put my, so that should be positive 3 this way and down 8. So over 1, 2, 3, and we're going to pretend that we're down 8, 5, 6, 7, 8 or something like that. Okay? Is this going to be going uphill or downhill? Uphill. What's the y-intercept? Hello. Why is it? Because the formula is x minus h.
Oh.
So h is positive 3, but since this is negative, k, but it's plus k, so k is negative. Okay? And the y-intercept I could get from over here. See, it's not negative 8. Okay? So the y-intercept is 0, 1 right there. So there's another point. And if I did want to find the x-intercepts, I can set this equal to 0. Okay? And I get x minus 3 quantity squared minus 8 equals 0. X minus 3 quantity squared equals 8. Take the square root of both sides. I get x minus 3 equals plus or minus 8, square root of 8. And I get x equals, I'm going to add 3 to both sides, plus or minus, this can actually be simplified, anyone know? 2, very good, 2 root of 2, right? And I happen to know that root of 2 is about 1.4, and 2 times 1.4 is about 2.8, and 3 plus 2.8 is about 5.8. So I could actually tell you that this goes through about 5.8 or something like that. So this, and then 3 minus 2.8, which is very close to over here, right? So it's kind of, you kind of get those intercepts pretty nicely and sketch your graph. That's not, my graph isn't to scale, but you get the idea. Yes? No? Okay. So that's good. And then for a parabola in standard form, so if you have another piece of paper, so if you have a parabola in standard form, f of x equals ax squared plus bx plus c. You know that the vertex can also be found straight away by plugging in, the vertex is at negative b over 2a, comma, f of negative b over 2a. You know what I mean by that? Right? So, for example, say I have y equals, I don't know, 2x squared minus 3x plus 4. And they say find the vertex. So this is negative b, so that negative b would be 3, right? Oh, I want one that works out nice. I'm going to change this number to 6. No, and change this number to 4. Okay? That's what happens when I make a problem. So I'm going to change this to 4. So negative b would be 4. And 2a would be 2 would be 4. So I get that this point is 1. So that's the x-coordinate of the vertex. And the y-coordinate of the vertex is what I get when I plug 1 into the function. So I take 1 in here. So f of 1, which is f of negative b over 2a, is equal to 2 times 1, which is 2, minus 4 plus 4, which is 2, right? So the vertex goes through the point 1, 2. Yeah? okay? And so I could kind of graph that parabola, at least I know the vertex, I know it's kind of squished, and so on and so forth. Also, axis of symmetry, which is the thing that cuts it in half. Axis of symmetry, all you really have to know is the x coordinate, okay? And that's just x, the equation of the axis of symmetry is x equals negative b over 2a. Exactly the same thing. So for this particular parabola, if I were going to graph it, it goes through the point 1, comma 2. I know it's right side up, so it doesn't, and it has a y-intercept that looks like a 4. So it's going like this. And the axis of symmetry, okay, comes down here, and let's change colors, and cuts this graph in half like that through the vertex, right? It should be straight. And so the equation that is x equals 1. Yes? Okay? I know I'm teaching a lot. I got a couple more things. I did cut down your homework, though, from what it was going to be, so you'll be okay. Yes, sir.
Still getting at the second part of
The 2?
Yeah.
I just took, you understand how I got the 1?
Yeah.
Just take the 1 and plug it into the equation.
Okay.
Okay? And then I got it. All right. Next thing, I'm going to talk about discriminants, which you might have heard about before. Uh-oh, that's okay. I'm okay. I'm okay. Don't freak out. Not positive. Okay. Discriminant. I never know how to spell that. D-E-S-C-R. I think that's right. And that's that part in the quadratic formula. That's the b squared minus 4ac part. You know the quadratic formula? Let's write it just in case. X equals negative b. We'll learn the quadratic formula song later on, but not today. No, oh, I don't know a rap. Is there a rap one?
Yeah.
Oh, you guys can sing that for us. Okay? Over 2a. And so there's some things about the discriminant. If b squared minus 4ac, okay, is greater than 0, okay, that means you're going to have 2 x-intercepts, right? Because if this thing is any kind of number in here, right, you're going to get some number plus or minus a number. So one's plus that number divided by another number, right? So you're going to have 2 x-intercepts or solutions, okay? B squared minus 4ac is less than 0. What's going to happen then? How many solutions am I going to have, or intercepts? None. Because, right, no x-intercepts or solutions. And that's because this would be an imaginary number, right? And you could have a real graph with imaginary solutions, right? It just doesn't cross the x-axis, right? That's what it looks like, okay? Here's 2 solutions, or 2 x-intercepts. And then you can have b squared minus 4ac equals 0, which means what? 1 solution. B equals 0, and you have exactly 1 solution. Because if you think about it then, if you think about that, if this number is 0, then you're going to have b plus or minus 0 over another number, and whether you add 0 or subtract it, it's going to be the same thing, right? And so 1 solution looks, it just touches your graph and then bounces off like that. So that's what 1 solution is. Okay, now I'm going to do one example problem and then I'll be done. Promise. And this example is important. Whoops. I ran out of graph paper. No, I have more. So find the equation of parabola's vertex. Find the, I'm going to go fast because I know we got 10 minutes. Equation 8 minutes of a parabola with vertex That's equation. Find the equation of a parabola with vertex 1, -5. 1, -5. And what else? And y-intercept -3. And y-intercept of 0, -3. And they want you to put this in vertex form. Okay? Uh-oh. In vertex form, kind of hard for me to write from. That's why I stand over here, because it's hard to write from this side. Okay? So what you do is you start with the general form of a parabola in vertex form, like this, x minus h squared plus k. And then you plug in this, 1, -5. So y equals a x minus what? 1 squared minus 5. Everyone sees that? Okay. Now to find out a, I need another point on the graph. That's how these people, those things on the wall, that's how they make their parabola go through certain points and make it curve how they want it to curve. Okay? So you take another point that you want your parabola to go through. In this case, it's the y-intercept, but it could be any point on that parabola, and you plug it in. So I'm going to plug in -3 for y, leave a alone, and x is 0, okay? Minus 1 squared, minus 5, and then I solve this for a. So I get -3 equals -1 squared is what? 1a minus 5. I'm going to add 5 to both sides of my equation, and I get that a equals 2. So now I could write my equation as y equals, I know a is 2, x minus 1 squared minus 5. Okay? And that would be the equation. Right? That's not hard, right? Homework! I'm going to just go to my website. So your homework is, move this. So it's on my website, but I'm going to put it up here. Index, free calc, chapter 1, 2, 3 assignments. Chapter 3, here it is. Page 160. Don't get, this isn't that much. 1 through 10 are like just short yes, no questions. 11 through 27 are matching, okay? Basically, maybe a little bit more than that. And these ones are more like you have to do something problems, okay? 47, 54, you have to come up with the equation. 69, 79, 81, and 103 are word problems that I want you to at least try, okay? So that's it, this one right here, all right? Okay, stop.